Welcome to this Maritime domain session as part of the buildingSMART International Standards Summit Valencia 2024. Thank you for joining. My name is Andre and I will be your moderator today. This is the first session of Maritime domain. The speakers for this session are Haijiang Li, professor at Cardiff University, Yi Wan, from the daughter of CCCC company. He will introduce himself later. Michel Reeves, Director Associate at Vianova, France, and also member of BSI Tunnel Project, the project manager. Si Liu, researcher, China Communication and Construction Company. This session is scheduled to last 90 minutes, including time for questions at the end. I will pass the microphone to those who are willing to ask questions. This session is being recorded and will be made available in the replay section of the event as soon as possible. For the attendees online, you will be muted for the session. Please, if you have any questions, write them in the chat. I would also like to bring your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of this code of conduct document. Now, I would like to hand over to Haijiang.
Thank you. Okay, I think Michelle should be here. No worries, we can start. This is non-competition law, so everyone will have a notice. This is all for same for all the projects. So today we are going to talk about the new maritime domain. Okay. So a little bit history. We have 90 minutes for this maritime domain session. It is a new domain, and before this, we did this port and waterway projects under infrastructure domain. And after that, we have quite a lot of new requirements that we feel that can come up with a new domain. So we call that as new maritime domain. And this is the background, and we're talking about ocean. So the 21st century, so the resources and energy and blue technology, they all come from ocean. So we think this is the big area that we should work on. And one of the initiators is from CCCC. They are a China Communication Construction Company. They have the leading expertise in maritime engineering. They do quite a lot of harbor, and they moving their focus towards to wind turbine, sea farming, underwater infrastructure. And together with other partners, like Roy Haskellin and other potential partners as well, so we propose this new domain. From this slide, you can see the different equipment, heavy machinery, and dredging, and also bridge engineering, undersea tunnel. So they're quite leading this area, so they're going to convert this into the standards. And so everything initiated from Rome conference is a good place, and then after 3.5 years, because of COVID, then we finally get the opportunity to come together and as community. So we signed an agreement between CCCC and buildingSMART, also including Cardiff University. I think at the time we started to talk to Michelle and talk to Chris Miller from Roy Haskellin, and together we finalized the proposal. And then when we moved from Rome, moved to Beijing, and there's a delegation from buildingSMART. As you can see, Clive, Aiden, and they visited CCCC headquarters. And finally, they signed an agreement that was 21st of August 2023. So here we are, Valencia. So we actually officially set it up at the 10th new domain. As you can see, we have airport buildings, constructions. So the last one is maritime domain with a new story. And those are the potential scope that could be included in this new maritime domain. As you can see, those marked in red would be the major focus for the stage 1 development. As you can see, the offshore floating structure, immersed tunnel, offshore wind power, and marine farms. So to begin with, we are starting with immersed tunnel. Those are the red that has high potential to be developed as second to third projects. Of course, we want a larger community from buildingSMART. There could be more potential projects can be proposed under this domain. So we're setting up the maritime domain, and that's how we follow buildingSMART rules, asking for the key player to come in to join us. So each player can have up to 2 committee members. So if your organization coming in, you will bring in 2 committee members. So altogether, we will have about 10 committee members to make mutual decisions with regard to proposal, progress report, working group setting up. And we have 5 or 6 now already in place, including members from CCCC, members from Royal Haskell, we have Michelle, we have Chris Miller, we have other people already sitting on board. So we are asking for more participation from other interested parties. So these are goals similar to other domains. We're talking about digitalization. Why in the first place we're talking about OpenB? That is digitalization for the enterprise that is we are driving. We're talking about collaboration, quality control of your data, and global consensus. So this is not one party's job, it's everyone's mutual community's job. So we are going to deliver the digital asset. And how to position this domain with other domains. Obviously, there are many domains already existing, and there will be new domains coming up from time to time. So we need to develop close linkage between these domains to share the commonalities. In fact, we have some common issues that are going to be resolved across different domains. One of the slides come from Michelle. He's going to mention some conditional geotechnics issues need to be resolved between infrastructure domain and this maritime domain. So we are going to develop open BIM environment and where the whole process, data integration, and build a unified digital construction mode and maintain close cooperation with other domain. Okay, that is about domain setting up. So we currently in a good position, and in minutes I'm going to explain, introduce some sort of new partners that potentially could be part of the team. I'm going to explain to you so that might trigger your interest to become a member as well. So currently we're doing these activities. We started with domain charter. Thanks for all other domains. They share their example domain charters. We based on that. This is then as a template. We already finished this first draft. So Michelle stepping in, Chris stepping in, working with our researchers in Cardiff University, taking into the consideration from CCCC, and we are working on this first version of charter. The next big thing is about the roadmap. So we are also developing the roadmap for maritime domain. As you can see, there are quite a lot contents from this year and next year, 2024, and we are promoting different type of projects. I'm not sure whether this project is working. It doesn't work. So there's many more projects that we're thinking can be included under this new maritime domain. So for the next following 3 to 5 years, we're planning that we are going to develop a whole set of this standard development through a new series of projects and to collect a good bunch of interested people together. linking to another project that we are doing is IFC port and waterway in infrastructure domain. That project, we are going to apply it in real project case, because now we already have IFC 4.3. We developed our standard already there. We want to apply it into real project context to see how good it could be for the open bin. Alongside that project, this domain, we're going to do this phase 1 new projects. So these two will be interlinked together. And another issue or task is activity proposal, and that is for our first projects, SMART projects. We're going to introduce this very soon. This is first documents we're working on. Thanks Michelle, thanks Chris, they're all commenting on these documents. We are going to finalize this soon and submit to this Maritime Domain Committee, or we have other domain committee to help to approve this activity proposal. Once we finish this activity proposal, we're going to move forward to project plan. We're going to plan the project in detail, then we're going to deliver it. And of course, we need more partners, interested partners. So at the moment we have CCCC, Royal Scanning, and YNAWA. YNAWA is the company's name. And we also have a small AEC3, ABCom, those SME companies to be part of it. And we have new partners that I'm going to explain to you. One of those is Laminar. So Laminar is a quite good new setup in London. They started like 2 or 3 years ago, but very quickly become multi-millions good pioneer company now. So one of our former researchers becoming one director there. So they're doing this beam-based project management, and they have business across the globe already, very rapidly development. So I managed to get them on board. So that is a slide from their company. So they're doing London Bridge Station, National Children's Hospital, serious hyperscale data centers. So also the data and cross-rail tunnel system-wide. They're very good at data management, and they're also doing the digital engineering, data analytics, digital transformation, and developing their software. So we have maintaining a good relationship with them. They are very interested in participating in this maritime domain. Perhaps they might be able to propose new projects. Recently, they're working with a big maritime project that in the West Welsh region. It's about wind turbine, ocean related. It's a very big company. They're setting the data management scheme with them. So we might be able to use that as another case study to be part of this domain. So as you can see, these are their the core business. We have a second one is X-Link company. They're doing this underwater cable manufacturing. So as you can see, this sea infrastructure, they need communications, they need fiber in communications. They also need electricity. Say if you build this wind turbine to store this electricity, you also need to transfer your electricity from the sea to the land-based. So this cable is quite critical. We have been talking to them. They are very interested, and they are now in the final decision stage to see whether they're going to step in. If they are going to step in, they're going to propose these cable-related use cases, because they need to install cables everywhere. When we're doing this floating infrastructure, we need cables. If we do this underwater infrastructure, we need cables. Literally everything for the maritime infrastructure, they need cable. So they need standardized environment for them to deploy the cables to. Otherwise, for different platform, they need different specifications. There will be troublesome for them. So they show a very strong interest to come on board. They do have a project in Morocco. It's UK power projects. using them to do this cabling. If they come on board, they might use that as another case study. Yeah. That's from Xlink. And this is Miracle UK Power Project. This is Miracle. It's a new thing that we have. We have many projects actually come from Miracle. Yeah. Okay. That is the story behind Xlink.
Is the defining challenge of our time. As extreme temperatures intensify, we urgently need to cut emissions from homes, travel, and industry. Increasing electrification is a big part of the solution, but our electricity will only be green if we rapidly grow new sources of affordable, reliable, renewable power. According to the Climate Change Committee, the UK will need a zero-carbon electricity network by 2035 to achieve the 6th carbon budget, to be on track for a net zero economy by 2050. Xlinks exists to capture the power of nature to generate a near constant, low-cost, clean energy supply and connect it to the point of consumption in real time. By generating solar and wind energy in Morocco and connecting it to Britain with proven HVDC technology, Xlinks can provide 3.6 gigawatts of reliable, renewable energy for an average of over 20 hours per day. A new solar, wind and battery storage facility will take advantage of the region's high solar intensity and convection current winds. An area covering 1,500 square kilometers will be capable of generating up to 10.5 gigawatts of zero-carbon electricity. Using the latest technology, 4 3,800-kilometer subsea cables will provide a dedicated source of power that secures Britain's energy supply. With an agreement in place with National Grid for 2 1.8 gigawatt connections in Devon, Xlinks can produce low-cost, clean power to over 7 million British homes before the end of the decade, meeting 8% of Britain's electricity needs. Crucially, Xlinks does not require any subsidy from the UK government and will provide firm and flexible baseload energy at half the cost of nuclear. Decarbonising the UK power sector by 2035 is critical if we are to meet our carbon reduction commitments. Xlinks can accelerate the path to net zero while decreasing the cost of the transition. Offshore wind is a crucial part of the green grid, but wind is vulnerable due to extreme fluctuations in output week to week. When the wind doesn't blow, the UK's reliance on carbon-intensive energy or expensive nuclear increases. While nuclear is an important element in the UK's energy strategy, it remains expensive and requires very long lead times. All this volatility means electricity market prices have reached historic highs. In the meantime, costs for electricity from solar continues to fall. According to the International Energy Association, electricity from utility-scale solar photovoltaic fell 85% between 2010 and 2020. Morocco has become a world leader in the fight against climate change by implementing very ambitious targets, including one that will see 52% of its power capacity come from renewable energy by 2030. Moroccan global horizontal irradiance is 20% greater than Spain, highest GHI in EU, and more than twice that of the UK. High solar intensity, 34% solar load versus 11% in UK, and wind resource, 52% wind load versus 31% in UK. Morocco's climate, geography, stability, proven experience in renewable projects, and local support paved the way for the country to become an international hub for price-competitive and carbon-free energy. Xlinks can provide predictable, clean energy the UK requires to get to net zero. A new, clean energy source, proven technology requiring no subsidy, reliable, flexible, baseload energy. Xlinks, capturing and connecting the power of nature.
So as you can see, different domains, there's many cross domains, mutual interests. So these also come from electricity, also come from sustainability. So now we want this project started with maritime domain first. Yeah. So for these X-links and laminar, so, we contact them. The final agreement hasn't been confirmed yet, but they show strong interest. The next one is also Syntaf. We also contact them. They have a researcher. We had several discussions before. So they are developing these maritime sea farming systems using digital tools to actually to linking different subsystems like water environmental quality control, fish feeding systems, and also the infrastructure floating cage. They're putting together different subsystems, linking together using digital systems to do this research. So it's very interesting. We mentioned this maritime domain from buildingSMART to them. They showed very interested potential. So we would like to develop this further. Potentially could be another partner on board. Okay, so that's about settings for our maritime domain, and we get progress well. And then we move forward. The first project under this maritime domain is Immersive Tunnel project. So this project has very good project background to support it, which is Zhuhai, Hong Kong, Macau projects. Yeah, so it has bridge, it has Immersive Tunnel. The Immersive Tunnel bit, we want to conclude it here to the best ISO standards. So we're going to explain that in details. So before going into detail, we need Michelle help to explain your, yes.
That's the button to the right.
Yeah.
Yes, so good afternoon, everyone. Sorry. Maybe just one word about myself. I'm running a company. It's called BNB France. We do big management on different kinds of infrastructure projects, roadways, railways. We've been doing a project that we were referring to in Monaco for the extension of a sea. So that's a major embankment. As a matter of fact, some data centers as well in the US for Meta, Facebook. We do big management there. Besides this, I'm leading the IFC for Tunneling Initiative for buildingSMART International. And I'll try to bring my past experience to this team, both from the perspective of what's the expectation from those who use OpenBIM, being those large projects, as well as how to best and as quickly as possible implement this standard that can be serving this OpenBIM methodology and OpenBIM approach. So, first contacts we had with Haijiang and the CCC team was related to the fact that initially in our IFC for Tunneling project, we had immersed tunnel as one of the subjects. But we dropped it. We dropped it because we needed to reduce the scope of our work to start with. But we knew we could help because we had developed components that describe the cut and cover structures. And an immersed tunnel, to an extent, is a series of blocks. It's prefab blocks, into which, of course, then a roadway or a railway circulates. So what you need for that matter is to, of course, prefab those blocks and land them properly on the seabed. And the seabed has to be prepared, of course. So not only do we have a basis upon which we can derive the composition of the different components that make up an immersed tunnel from what we have already in the IFC for Tunneling schema. But we've developed as well a rather large, significant specification for geotechnics. So everything that relates to boreholes, laboratory tests, geological model, and so as a result of the interpretation of raw data, everything that can carry seismic information. And then every component that is exchanged between the geotechnician and the civil engineers when it comes to basically choose the proper civil engineer solution given the geological or geotechnical situation that is encountered. with all the risk and the uncertainties that go around this part. So that, we believe, is something that would directly serve the IFC for immersed tunnels strategy. And the last part is that because we were in the FC4 tunneling project, we were dealing, of course, with underground excavation. We had to assess what was already there in IFC that covers cut and fill, so basically earthworks. And to a large extent, undersea excavation, so seabed preparation, seabed cut and fill, is very similar to what you could call open air cut and fill. And that part we need to improve to cover properly the needs for the IFC4 immersed tunnels. And that's a shared need, given again the fact that we've covered the underground excavation as part of the IFC4 tunneling project. So those three reasons made so that we have a shared common interest in moving forward, and I believe that we can move forward quite quickly and quite efficiently, as a matter of fact. A few words maybe just from the implementation side of things. You may have seen that in the past, but this is important to say two things actually. I wanted to comment back on what you were talking earlier on. Starting a project of that nature, we need to find a set of partners, being either those who financially support the project or those who bring in-kind expertise that represents the different types of actors in the industry, meaning infrastructure owners, meaning consultants, meaning construction companies, and meaning those who operate the infrastructure or the projects. And in addition to that, we need to have as well software vendors in the loop, because having software vendors who provide solutions for that industry will help, of course, speed up the implementation of the standard and then make those solutions available to the industry. So it's a win-win situation, both from the infrastructure owners as well as from the software vendors. So the roundtable of stakeholders in the project has to shoot for having those different types of actors present in the board, in the steering committees. So that's important really. So I believe we mentioned as well the Finnish Transportation Agency, because they have quite a lot of waterways in Finland. They are interested, express interest. And likewise, Trengol in Norway, they have a design solution for waterways, which could be a good example of how to implement. Plus, they have solutions for tunnels as well, and they've used those solutions as well in the case of the immersed tunnel in Oslo. I don't know whether you know the configuration of Oslo in Norway, but there is a quite significant immersed tunnel that's going under the floor at the bottom of the fjord and avoids the city itself. That's always a very good case of how BIM for immersed tunnel can be used. So, from this one side, we just bear in mind that we put a proposal to start with that is based upon, of course, requirements. We need to get to a specification that leads to a candidate standard, and that candidate standard, once being assessed by BSI, gets into a final standard stage, which is then integrated in the production system for publication by ISO. And here you have this loop that goes around having software vendors approve or help refine the specifications that we put together, so that those import-export abilities with an open BIM IFC for immersed tunnel is indeed supported. So that's why this is rather key. If we look a little bit more into the main steps to start with, I think we are close to have the content of a work plan, in the sense of defining the priorities when it comes to this one particular sub-project, I call it a sub-project. But then the next action, basically this describes our intention. The next action will be around specifying capturing the requirement from the domain, from the industry experts. And that can be quite time consuming, because it requires, of course, that we get to a consensus. And consensus, by essence, is an international consensus. So we need to be, even though the group that provides or that produce the requirements is limited, we need to be sharing it and getting consensus from all the regions in the world. And that can take time. To start with, by identifying the ones who have an opinion, that's already something, making sure that they have a relevant opinion, and then capturing their feedback. And that requirements analysis document will lead to taxonomies. This is typically where we get to. So it's a list of the different components that make up a project, and what are the functional capacities, and what are the characteristics of those different components. Then from there, we'll develop more on the IFC side, the extension of the schema itself. And there, this is something that will lead us to involve software vendors as well. And then next, of course, is to help software vendors to implement. And the experience that we've had with the IFC for Training project shows that if you don't push and if you don't drive software vendors to implement, it can take much more time than you would expect, and you need the stakeholders to pressure, you need the infrastructure owners to pressure, you need to have all the main actors in the market pressure the big software vendors. And last but not least, you need to prepare a set of real-world data for those software vendors to test and for the stakeholders to validate basically the outcome. So this is back to the main, if you will, actions that we will need to undertake. This is rather, systematic in every BSI project. And then these were a few cases where we identified as real case scenario where the result or the specific, actually the requirements should come from, and when the result should be tested. You want to comment on this?
Okay. Yes. So this is I mentioned earlier is Hong Kong, Zhuhai, Macau link. So this is combined different type of projects. They have road, they have bridges, and in the middle that is underwater tunnel, so immersed tunnel projects. It was so complicated. It takes there's other like Shenzhen Link undersea tunnel, Dalian Bay undersea tunnel, Shenzhong Link, also the bridges. So all this was experience best practice. They are now to try to conclude and to contribute to developing open BIM standards through this buildingSMART channel. Okay, and those are the other different type of maritime domain related projects. The immersed tunnel, Shenzhen Link, the world's first immersed tunnel floating installation with ship. So as you can see, this heavy machinery is also critical in terms of to do this immersed tunnel construction. So otherwise, without those machines, it's mission impossible. So you cannot actually finish it. And then you also have immersed tunnel construction and fixed depth horizontal excavation control system. Now, those are the heavy machinery that are related to immersed tunnel that we are going to define as appropriate use cases to explain this properly.
So as you've understood, we are not going to be covering only the design part, we'll be covering as well the construction part. So it's not the what only, it's the how to as well. Yes, I was referring to this project in Monaco, which consisted of an extension through an embankment that is built of the sea here to create a platform that will extend the city. This project is actually under construction right now, but at the time we helped the main contractor, that is Bouygues Construction. We had not followed through or anything like that at the time, so we've tried to help them understand the value of using an open BIM approach in the context of a project of that nature, and that's really concentrated. That really was focused on the construction aspect of things. So the construction methods, sequencing of operation, the supply chain optimization, that kind of thing. So we have a little video, so it's self-explanatory. So, but basically, there was this idea of componentizing the different major part of this project, which is made of a series of caissons here, which were built prefab, brought on site, and then landed onto a seabed that was prepared. Let us play the video, you understand everything. Just pressure. Yeah, good. I think we have just 3 minutes.
For Monaco's seaside urban extension project, Travaux Publics has developed unparalleled construction methods to minimize site impact on the environment. Enabling 6 hectares to be reclaimed, the infrastructure is, for the main part, built from the sea. It is made up of reclamation ground surrounded by a concrete caisson belt placed on an underwater backfill. It can accommodate a small port. As early as 2014, with its partners Tractebel, Andromède, Oceanology, and DHI, the consortium carried out an impact study to pinpoint the site's environmental challenges and integrate them into the project's core conception and execution methods. Even before the start of works, the first environmental actions are implemented. 47 large noble pen shells are moved to the Grotto Marine Reserve. Continuous turbidity monitoring devices and 2 anti-turbidity underwater screens are set up around the site. Finally, a noise protection screen is built along the shoreline. Dredging operations will then begin. Silt is extracted using an excavator with a watertight ecological grab to avoid suspending material. The first riprap layer of the Portier dike is then removed to create nearby ecological artificial reefs. To keep turbidity levels down, a dredge sucks out sediment without discharging water. This sediment is taken to a deposit location, specially chosen to respect fauna and flora at a depth of 200 meters. Backfilling can then begin on the exposed rocky floor. Quarry-prepared materials are stored and washed in the port of Toulon. They are loaded onto a dedicated ship and delivered to Monaco after a 10-hour sea journey. Robotized piping then positions them as near as possible to the sea floor. After reaching its final level, backfill is compacted by floating devices, then adjusted via an underwater grader. Throughout these phases, site teams pay particular attention to sound and light emissions to limit impact for local residents. At the same time, in the port of Fos-sur-Mer, production of 18 reinforced concrete caissons, making up the new district's protected belt, will start. 26 meters in height and weighing 10,000 tons each, they are built by continuous casting in a large floating metal structure known as a caissonnier. Once concrete is poured and the weight of its structure increases, the caisson-caissonnier unit slowly sinks. After being floated, the caissons are completed, prepared, then towed to Monaco and run aground on the backfill foundation. They are ballasted with seawater, then weighted with quarry material. Developed by Travaux Publics R&D teams, its specialized biosensitive structure, together with specialists in ecological restoration, the caisson's facade is fitted with devices which can accommodate sea fauna and flora. Once the caisson belt has been finished, construction of the reclamation ground begins. This is done using sea sand, extracted from the north of Sicily by a suction dredger, displacing a mixture of sand and water that settles in the new enclosure. Water from this decantation is pumped by the dredge. It is not discharged onto the site. All these precautions help restrict turbidity. After final reinforcement work, the platform is ready to receive the new Eco District. The overall project is scheduled to be executed within 50 months, of which 40 will be needed for Bouygues Travaux Publics teams and partners to complete this ambitious worksite, essentially carried out from the sea. The eco-designed sea structures and artificial reefs will constitute new ecological corridors. The nearby Tombon des Spelluc coral reef will be restored. The management plan, drawn up by the Principality in cooperation with the consortium, will ensure overall long-term project cohesion. Respecting the site's strong environmental requirements from both natural and urban points of view, this project affords Monaco an opportunity for harmonious development, respecting residents and nature.
Right. So as you've understood, that there is a lot of considerations around, biodiversity and sea life protection and so on and so on and so on. This was made to illustrate the intended construction process at the time. So that's like 2016. It's been now, I believe, the platform has been now delivered to the architects. So it might have taken more than 15 months that this was announcing. But anyway, it's, I think it's still a very terrific project. Yes, and so as I was mentioning earlier this morning, if you are interested, number one, I believe that all the big villas are already sold out, but the flats, if you have like between 50,000 and 80,000 euros a square meter to spend, then you can probably try to apply. Back on what but this is an interesting case where you can illustrate the value of using a new approach. Back to what I was saying earlier on quickly in terms of what we are preparing. First thing we need to do is, as I said, we need to capture the domain experts' requirements. That's the first thing. Then we will lead to a design a conceptual model, which will then lead to the extensions themselves. All this is to be built together with the domain experts. And looking at qualifying the scope of what needs to be covered, not only design, as we said, construction, simulation and sequencing. Tender phases is worthwhile thinking about in terms of what do we exchange exactly with the different actors in the project. And the monitoring of the construction itself, the recollection of what has been built, and the handover to back to GIS, as we said this morning, or back to assets management for maintenance and operation tracking purposes. Geotechnics, I said earlier, I believe we have covered, so that's already an important part that's behind us. A few words really on the way to move forward in terms of developing this project. There are modeling guidelines which are clearly specify how things should be modeled from an IT perspective. The tooling there basically classifies whether we are using, extending, or amending some concepts, some entities, classes, object classes, if you will. All this is documented and which provides a way for everyone to understand how the project is moving forward and to participate into it actually. So bottom line, at the end of our work will be extending the different domains with the maritime domain, and it will be probably sharing us a few concepts and a few object classes, no doubt about this. And when it comes to the tooling itself, use enterprise architect to do this modelization. This is interesting because you can share that kind of support images and tool with the domain experts to make sure that we got the relationships between the different concepts right, and that the domain experts and the IFC experts share the same understanding. This is a very interesting exercise to drive to get the two communities to understand each other well. Right, likewise, again, like on the documentation that needs to be produced, and all this is to be made available as the progress as the project moves forward. Some of the documents that you mentioned about, like the charter and the other project proposal, activity proposal, they are in a stage where kept within the project team, but they are at the stage as well to be communicated to the outside world in a public way. So we'll be organizing a public access to all the documentation that we produce. You want to talk?
Okay, excellent. Good afternoon, ladies and gentlemen. I'm Lucy from CCCC, and next I'm going to demonstrate to you a use case study, which is dedicated for the power calculation, where we use IDM, MVD, IDS, BCF, and BSDD, and all the open beam tools and the philosophies to this use case. And the reason why we want to create a small use case is because the whole duration of the FC and open beam development is really long, or 3 years or 4 years or 5 years. So our idea is, first of all, we maintain the current BSI and standard development process, and in the meanwhile, why not we can learn some experience from the software developments. We can use a sprint development, and then we summarize the good points and bad points. Then we can iterate and to keep climbing. So that's the reason we make this power calculation use case. And the current problem for this business use case is there could be 3 software along the process, and there are different data model in different software, which means the software cannot communicate to each other. So our working efficiency is pretty low. So the solution is using open beam. And the first step is always go to the IDM. IDM is we believe the starting point when we making the standards, because we need to map the current process and making it as much as standardized. And also there are a lot of points, process points along the IDM process, which is the UCM, user case management. And we standardize the user case management and try to analyze what's the main function, what's the input, what's the output for this use case management. So that's the starting point. And second is, once we have the IDM and the UCM, we can move forward to the BSD part. So in this case, we need to standardize two elements. First one is the power. Another one is the geological bore. And we talk a lot to our designers to define those parameters. For example, the power should have a pure number, pure mark, root elevation, and position X and Y, pile elevation, diameters, calculation length, and the design length. And also for the geological bore, it should have the soil number, index, name, bearing capacity, skin frictions, compressive strength, and the gamma number. So this phase also takes some time because we need to have lots of interaction and discussion to the designers. And then the next phase goes to the FC. Because when we define the parameters of the object in FC, we should refer to the BSD we predefined, and also the MVD we use for the power calculation. And the final part is the software developments. Horizontally, we define a whole data stream, and in the middle of it, it's just a data center where we want to store all the information in the data center that can be used by different softwares. And we developed 3 softwares. One is the geology software, design software, and the calculation software. A different software is communicating to the data center via the web interface. And the outcome is we have developed the standard, the software. Also, the final outcome is the calculation sheets, which means the whole process is complete and the designer can deliver this calculation. and ship to their clients. And conclusion is we have standardized business process, we have unified data structure, and we have a smooth data communication. So that's the conclusion for this case study. And our next step is we keep moving in this way and scale to more use case and trying to accumulate the assets and make summary. So that's our conclusion for this case study.
Hello, good afternoon, everyone. I'm Wang from CCCC. Now, I would like to introduce a large-scale sea farming project in China. The project total sea area is about 94 square kilometers and is invested, constructed, and operated by CCCC. The project total investment is about 600 million euros. The project will be implemented in stage and fully completed by 2029 with an operation period of 15 years. This project is located near Dandong City, Liaoning Province in the northeast of China. Particularly worth mentioning is it is the first large-scale PVD sea farming project in China conducted by CCCC. The project is including 3 types of reefs and artificial fish reef area about 10,000 acres will be built, such as single-hole square fish reef, upwelling current reef, sea cucumber breeding reef, also hard to read. And the project will build 2 types of deep farming net, adopting gravity net cages and intelligent breeding troughs. It also has floating breakwater. The total height is 4.7 meters with a total height of 2.75 meters. It is about 1.25 meters above the water surface and about 1.5 below the water surface. Okay, next one. We built supporting facilities for this project, such as yacht couple, island landscaping, entertainment facility, and a large supporting warehouse. Next one. Shared warehouse of 40,000 square meters too. Okay. We are preparing to adopt an integrated early warning sea farming system to monitor environment, waves, and tides, fishery healthy and equipment operation, and so on. Okay, next one. We have conducted research and design work with institutions such as the Ocean University of China and ATVA in Norway, and have completely special research reports such as the project feasibility reports. And we are also collaborating with universities and research institutes to conduct research on key technologies for the project. It's my sharing. Does Professor Lin need to add anything?
Okay. Yes, as you can see, there's quite a long presentation because we combine everything together, so to form a big one. And we actually proposing the first one, immersive tunnel, and this is the second one that potentially can be further developed as a full-scale project. As you can see, this project is very, very attractive, interesting, and massive investment already happening, and this investment plan has been approved. So they are going to construct it to finish by 2029. So we feel this is an excellent opportunity to include this one as second project. And also, If thinking back, we have new partners that Lambda, Xlink, Syntec, they potentially can bring in the new project as well, including that geotechnical perspectives. We're talking about sub-projects within those projects, but run it across different domains. Linking back in the morning, we're talking about port and waterway, because that stage, we move to stage 2. We are applying it in the real project. This one will also apply in the real project because we have already accumulated good experience with using OpenB. So this time we get to see how far we can go to eventually solve this problem for industry. And hopefully we get more interested parties to come on board. And we welcome any questions and any queries, comments. And so it is. Chair, want to add something?
No, not really. I think that this is a very dynamic industry. Major projects who have the financial capacity to be sort of prototyping the use of a new collaborative BIM approach to their benefit, of course, to start with, but to likewise make sure that we have use cases that are sufficiently relevant in the sense that they can be replicated. So I think that those two first sub-projects can really lead to extensions of the current schema that will really serve the industry. So I think that this presentation was very much about making a call for interest. It's not the final call. Yeah, please, anyone interested in this in this industry, in those projects, contact Haijiang, or relay the message, because I'm sure that there are, for example, we've been talking with people like Petrobras, so they are like in the offshore oil and gas business. Nothing to do with sea farms, but still at the end of the day, they need to be creating those huge infrastructures and the sea. And I think that we have there are two another field where what we'll be developing can be applied.
That's great. So we have about 30 minutes to discuss. And if there's a requirement, we can definitely stay.
Do we have any questions from the audience?
Maybe top one. Why should just no, it's okay. Why should extending IFC schema but not using a dictionary from build a dictionary from BSDD directly? But I think it's kind of like the same thing, but with the extending IFC schema is quite long, and maybe we can test with dictionary, BSDD dictionary, and later if all of those dictionary classification and properties is all valid in all kinds of use case, we can push the schema directly to the schema in, I would say, next word.
I think that's a very good question.
Yeah, why?
Answer first, and we can something, yeah. Because this BSDD is a very good approach. Hence, we also include BSDD in this development. But this area, we feel the maritime domain is quite intensive. So we feel that might not be able just by extending from the existing schema and to put into BSDD, that would be enough. We actually tried both. So because we have this capacity to do it in a massive way, actually, to further expand IFC, to make it into even deeper granularity, that would be enough detail for industry to take on for the practical practice. At the same time, we also develop the BSDD. Like IFC Port and Harbor, Tunnel, all these projects will contribute to BSDD as well. Like what we discussed earlier today. So there will be different versions of BSDD, different contributors from the BSDD. We need to make sure the quality-wise that can be used with good quality by the user. Actually, CCCC also participated in this accelerator program, where BSDD is one of the key components that they need to contribute. Actually, the engineer Johnson also from subsidiary company of CCCC, they're dealing with road infrastructure. They are developing BSDD for road. So as you can see, I think that will answer your questions.
If I'm not mistaken, I think that you correct me if I'm wrong. I believe that BSDD is very good at dealing with classifications, whereas you have on the FC schema you have the conceptual model. So you basically link the two, but you still need the conceptual model on the left side to be linking to. Am I correct? No. No opinion? No. I thought you had an opinion.
No.
Okay. Can I ask you, Kanizari, out of your experience with us as a domain expert within the FC4 tunneling project, would you have any pieces of advice to give to this new team that is setting up? What to do and what not to do, for example?
Yeah, I think the having experts, domain experts is quite important and helpful.
So I was just thinking that listening your first part of presentation, you were talking about steering committees, the structure of the domain and stuff like that, but I haven't heard of domain experts. Are you thinking about having domain experts for like sea following or immerse tunnel, wind turbine and stuff like that?
Oh, thanks for the reminder. It is, oh, yes. Thank you for the reminder. I think we missed that point definitely. But that definitely is one of the core team building. Internally, as a core team, we have technical delivery team. But for the domain, we have a domain admin committee member. But both in domain and for the project level, we need large amount of domain expert from worldwide, from Japan, then from China, from Europe, France. Because now we're actually approaching them through our academic link. So we are from university. But we also encourage all our partners for themselves to be part of the expert team first, and also from the connected companies to become part of the expert. And those are the major resources that we can leverage in terms of to do this requirement analysis, to define the user cases, to define the precisely about the scope, because there are parallel domains now is ongoing. We need to carefully design the boundaries somehow. If that's a requirement, we need to define the boundary between different domains. So expert is definitely valuable resources that we are looking for. So if you could be interested and then can participate in this domain, that would be great. Yeah, we'll be very happy.
And if I may, being part of this, of a team like this, and because Marie, you know this well, requires as well some level of commitment, even though you are not like driving the project, but you are being asked by the domain team to contribute or to validate options and things like that. And maybe just on the past experience of the FC4 project, we have, I think we've organized our team 4 teams. We had 3 domain teams, some experts, and then we had a technical team. The domain teams were meeting up once a week, once every other week, but it's been quite intensive an exercise. Then the tech team took over, but then we needed to go back to the domain teams, and we were having like, for example, since the summer last 2023, we've been having probably between 2 and 3 meetings a week with the domain teams. It's not one day meeting, but still, it requires a commitment, no doubt. But that's the key to provide something at the end that is used by usable by the industry.
Thank you very much.
Any other questions?
Short question. Will the result of this project is be included in IFC 4.4
or will it be in IFC 4.5 or next generation?
Good question.
Good question that I don't know, but what I can tell is that we have with 4.3 and the extensions that Turing is bringing a solid platform to add that kind of it doesn't require per se a new generation of IFC to serve the industry. It seems as I've understood it, IFC5 is more like a re-architecturing of some part of IFC. I think this is more naturally related to the current space-time, I would think.
Yeah, you can add a little bit. Because this is a very good question. I'm also thinking the same timeline. Because now there's IFC tunnel is closing. So I think you are aiming at IFC 4.4. Yeah, so I'm talking about half year or 1 year time scale.
Well, we as a project team are ready. Well, not exactly ready. I'm sort of being a little bit optimistic.
But yes, probably by the end of Q2 we are going to be ready. Now I know that there are another bunch of fixes that, for example, the buildings teams would like to get into the next phase of IFC. So I don't know whether it's going to be called 4.4 or 4.3.x. But again, as far as the material, the core material, we have what we need to extend to serve this those sub-projects.
Having said that, I do have some ideas. Maybe we can, use different phases for this maritime immersed tunnel. We can have some light touch of this definition of those use cases and concept, and to become timely to be included in IFC 4.4. And then we continuously, after the IFC 4.4 published, we continue to develop this new concept into BSDD.
Yeah, I got a thing to ask. I don't know. Thank you. It's just to continue the idea from Professor Haijiang. If we can to get a common sense for the part of IFC tunnel 4.4, in the definition and the structure, if their definition and their p-set properties and the type and the enumeration, it's compliant with our definition in immerse tunnel. We can use the IFC tunnel plus a BSDD dictionary. Data dictionary for additional specification in our requirement, maybe high pressure in undersea, but it's an additional p-set attached to the IFC tunnel. If this can work, maybe it's good. Yeah.
I think part of it will be that, yes. Because as I said earlier, we have, I believe, enough or good enough stuff that covers cabin covers. So those definitions of blocks and the way they define, and that can be derived into additional properties that can be maintained.
Excuse me. So my point is just are we need to alignment with IFC tunnel project to make sure there is not kind of any conflict between our definition and
the first action will be to assess whether what we have serves the purpose right or not. And I think there will be, of course, that.
Yeah. Is it working? Yes. Working, yeah. I think we do have some plan for that part. To begin with, we need to start to do critical analysis to understand the differences and overlapping analysis to understand the difference. Once we set it up, we are ready to go. I think your solution could be technically viable. I think maybe we can do it, but also the strategic policy come from CCCC and come from those partners, and we need to, of course, discuss that in more detail. I'm also linking to your question regarding to the further development. I think even in IFC 5, I do have some interesting idea with Leon talking about what's going to be IC5. I know that's a big question for everyone. But even though in the IC5 in the future, there's still need for the domain knowledge to be keep on developed. So we can still using this project style to develop this new concept to fit into the IC5. Now IC5 will come into the AI, all these new technologies and this service oriented, it doesn't matter. Underneath, they still need to have this domain knowledge.
Do we have a conclusion? Okay, good.
No more questions? Then I would like to thank all the presenters for the session and all the attendees. We're looking forward to seeing you at other sessions of the summit. Thank you.
Thank you, Andrew, as well.